Good morning. Today we're going to talk about angles, and you've discussed angles for years, and so you're probably wondering what new could he tell us about angles at this point. We've used angles forever. That'd be like saying, "Hey, let's talk about whole numbers." Oh, this is simple. Well, trust me, I'll find some way to make it difficult. So let's look at angles. Usually we measure in degrees. Okay, so degrees. Let me get that pen cap off. Degrees. I'm going to make a little chart here, and we're going to start with 0 and go up to 360. So then we're going to get the 0, 90, 180, 270, 360. And hopefully these numbers ring a little bit of a bell to you. They're 360 degrees in a circle, and so these are just different partitions. These are the different right angles up to 360 degrees. Now we could also have radians is the new thing we're going to use, radians. And you can see in your TI-83, which I don't have right in front of me, but if you go to mode, you can switch it to radian mode, and that does this instead. Okay, 0 is 0, and the whole way around is 2 pi. So half of 2 pi, half of 360 is 180, half of 2 pi is just pi. And then halfway from there, it's going to be pi over 2, and then pi plus half a pi is 3 pi. Over 2. Okay, 1/2 plus 1 is 3 halves, so just keep a pi on there. When we're working with radians, there's always just going to be an extra pi floating around. So if you can remember that's where the pi is, that will serve you well. To go from, this is what I'm going to kind of look at right here for the conversions. To go from degrees to radians, degrees to radians, and it would be the same across the board. It's a common multiple. It's a direct variation. Let's use this one right here because it's the easiest. So to go from 180 to pi, I will multiply by times by pi over 180. That will cancel out the 180 and put the pi there. And to go the other way from radians to degrees, from radians to degrees, you multiply by the reciprocal. Multiply by 180 over pi. That's how you would switch between one and the other. So we have this new measure of angles. We call it radians, and why we use radians is kind of a calculus question, and we're not quite there yet. But one thing, I want to look at arc length first. So we'll answer that question as to why we use radians, but we need to do some calculus first before we can really understand this. So for now, just trust me. Okay, but I want to look at arc length. Arc length. And this is going to be of a circle. Let's just put of a circle there as well. So the whole way around a circle is, well, let's see, the whole way around a circle is the circumference. Circumference equals, what, 2 pi r. Okay, well, this 2 pi here is really a angle in radians, okay? Radians, 2 pi is the whole way around the circle. So the arc length, which for some reason they use S, and I don't know why, but I'm going to go with it to avoid confusion later on. Arc length, they use an S. Just put whatever the angle in radians is here. So I'm going to use theta for that. This is the Greek letter theta times r. So the arc length is just the measure in radians times r. And let me do a little picture of that so we can kind of see what I'm talking about here. So here's my circle. The whole way around is the circumference, but I just have an angle theta. Just have an angle theta I want to think about. There's theta. Okay, and what is the length of that arc from there to there? What is the length? Well, that's what S is. If you take the the measure in radians times the radius, that will give you the length of that bit of line there. Okay, so that is the formula for arc length of a circle. It's very closely related to circumference. So if you forget this formula, just take your circumference and put 2 pi, and put theta instead of the 2 pi. Okay, one more thing. Oh, great, thank you. Oh, thank you. Sorry about that. One more thing here. Let me see where my notes go. Here we go. So I want to talk about degrees, minutes, and seconds. So this has to do with degrees. Let me just put degrees, minutes, and seconds. Okay, just like on our time, you can divide time up to minutes and seconds. You can do the same with degrees as well. So let's go ahead and try this. Let's say you have 37.425 degrees. Okay, well, we can change this into degrees, minutes, and seconds. So let me get my calculator. Sorry, I had to run over there. I have plenty of distractions here. Sorry about that. Let me fire this up. Oh my goodness, second plus 712 it. Okay, so 37.425, and the calculator will do this for you. Let's see, angle is right above the apps key, so second and angle. I'm going to convert this into degrees, minutes, and seconds. It's right there. Okay, so 37 degrees, 25 minutes, and 30 seconds. 37 degrees, 25 minutes, and 30 seconds. Okay, now just to think about what this means real quick here, a minute is a 60th of an hour, so it'd be a 60th of a degree. And a second is a 60th of a minute, which is a 60. So really, this is 1/60th. This is 1 over 60 times 60, right? Because it's the 60th of this, which is a 60th of this. So this is 1 over 3,600, 60 times 60. So just to verify this, I can add that up and see that it comes to this same value, just to kind of understand where this is coming from. So it's not black magic or anything like that. It was really what it should be. So let me try that out. I'm going to do 37 plus 25 over 60 plus 30 over 3,600. And that will give me 37.425 back. So that does work out. So you can also do this. You can say 42 degrees, 24 minutes, and 36 seconds. And I'm going to change this into just a decimal. Okay, well, I can do this thing I just did, which might be probably the quickest way to do it, but there's another way the calculator will do it as well. 42 plus 24 over 60 plus 36 over 3,600. And that gives me 42.41. Okay, the other way to do this is going through the angle menu. So let's see, it's 42 degrees. Under the angle menu, there's degrees. And then 24 minutes, 24 under the angle menu, there's minutes. And 36 seconds. The seconds is above the plus key. You have to hit alpha and plus, and that will give you the seconds. And type that in, you get 42.41. So either way you want to do that, that'll be fine. So 42.41 degrees. And I guess one thing I should note here now that I'm thinking about it, when you have a degrees, we always use this degrees symbol. Okay, so let me go back up here and correct my notes. This was terrible. Radians has no unit. There's nothing you put on radians. Okay, so 180 degrees, 180 degrees. Do I got them all now? Good. Okay, so degrees has that symbol. Radians has no unit. Leave it alone. So that is your introduction to degrees, radians, arc length, and talking a little bit about degrees, minutes, and seconds, which has some practical application, but we won't talk about that. Degrees, minutes, and degrees, minutes, and seconds, we won't talk about that much beyond today.